welcome to this episode of Bill Snodgrass. And this episode, I'm just gonna be only a few people. This is like me and this guy who requested me making this video. We're gonna like this video, and then a few other people. So you may not like this video, but go ahead and hit the like button, subscribe to the channel, sign notifications, all that stuff. We're gonna derive the distance equation. What is the distance equation? The distance equation is the final distance, d sub f, is the initial distance, d sub I, plus the initial velocity times time plus 1/2 the rate of acceleration, t squared, where a is the constant rate of acceleration, accelerating at a constant rate. Let's break it down. What is d sub f? D sub f is how far something is from a reference point at the end of whatever the t is. So how far is a satellite from the space station after 5 minutes if blah blah blah, all that stuff. How far is a ball rolling something from the starting line, a track runner? D sub f is how far something is from the reference point in whatever is going on. D sub I is how far did it start from the reference point. So this equation is how far did it end up, and we can break it down logically into, well, how far was it to start with, and then how far did it move, or what is the magnitude of the displacement, and we're going to call that delta D. So we can take this equation that we started with, and we're going to just jump over here as we derive this, and we're going to call it this. The final distance is the initial distance plus delta D, where delta D is the displacement. How much did it move? So delta D, what is delta D? Well, delta D is found over here. We'll go to blue. I'm doing some scratch work here. Delta D is how fast was it going and how long did it move. So we're going to call this V, the velocity, and T, how long did it move. It's going to change, the displacement is going to change based on the rate of motion, velocity, and the T, the amount of time that it moves. But we have to consider this V a little bit differently. In this case, it's going to be the average velocity, because as something is accelerating, the velocity is changing. So we're going to squeeze in here AVE, the average velocity. Well, what is the average velocity? Well, average velocity is equal to how fast was it going to start with, and then how fast was it going at the end, take the average. So that's VI plus VF divided by 2. VF, the final velocity, let's take a look at that. Final velocity, we're going back to black. VF is equal to how fast was it going to start with, and by what amount did it change velocity. So that would be delta V. Delta V is a function of the rate of acceleration and the amount of time. So if something is accelerating at a rate of 2 miles per hour per minute, then after 2 minutes it will be going 4 miles per hour faster. So delta V is equal to A times T, where A is the constant rate of acceleration and T is the amount of time. So I'm going to substitute that in here. The final velocity is the initial velocity plus A times T. Now I'm going to take this V sub F. I'm going to take this V sub F and I'm going to put it into this equation here. but I'm going to write it over here on the side. V average equals VI plus VI plus AT divided by 2. Algebra, V average equals 2VI plus AT over 2. Now I can divide this. I can divide this out, and that will give me the average velocity equals VI plus 1/2 A times T. So now I have the average velocity. I'm going to take the average velocity that I just calculated, and I'm going to use it in this equation. We're going to do that over here. The change in displacement, delta D, is equal to the average velocity, which is this, VI plus 1/2 AT times T. I'm going to multiply the T into the parentheses. Delta D equals VIT plus 1/2 AT squared. Now I'm going to take this delta D and put it in here, and that is going to give us this equation. So we start with the average velocity formula. Use the average velocity formula to find the displacement, the change in displacement, and then we're going to use that change in displacement with that equation. So all of this comes from here, and this comes from here. All right. Thank you for watching this episode of The World Around Us. That's where the distance equation came from. Hopefully this made sense, and hopefully you will like, share, comment, all that stuff. See you in the next episode. It makes perfect sense to me.